So in the first lesson we saw that if you took two squares that had area of 1 and a combined area of 1.5, of a combined area of 2, and you cut this guy down the middle, and this guy blue, this guy red, this guy blue, and you assemble the three pieces, it would look something like this. And although this isn't a square, we know that its width is 1.5, so this is a 1.5 by 1.5 L-shaped thing. And from that we said the square root of 2 should be less than 1.5. Now, to make a better approximation of this is a very clever idea they came up with, which is this. The issue is this missing square here. So if I can somehow take some of the material, imagine this is like made out of metal, and fill in this little hole here, I could get a square, or maybe something that's still an L, but with an L with a smaller missing square in the corner, whose area is still 2, and whose width is going to be close to the square root of 2. So again, the idea is that if I had something with a smaller square in the middle that still had an area of 2, this width would be approximately the square root of 2. And here's the clever way of doing this. Here's our thing that's 1.5 by 1.5. This little missing square is 1/2 by 1/2. Remember, 1/2 was the height of this rectangle here. The idea is, and this is very clever, if we shave off a tiny little sliver from here, how big should that sliver be? How wide should it be? Well, it should be wide enough that it would fill in 1/2 of this missing square. In other words, we know that that rectangle, this black rectangle, is 3/2 times x, because it's got height of 3/2, width of x. We want it to be 1/2 of this square here. Well, this square is 1/2 squared, so it's 1/2 of 1/2 squared. This becomes 3/2 x equals 1/8. Multiply both sides by 2/3 and get x equals 1/12. Now I can do the same thing if I also take a sliver off the bottom. We'd have the same situation there, where this bottom sliver is going to fill in the other 1/2. So what I end up with, if I actually filled in, there's a little issue I haven't mentioned yet, but if this works properly, I end up with a nice square now. But by shaving a little bit off of these sides, they get smaller. So this is no longer 1.5, but this new guy is 1.5 minus 1/12, which is 1 5/12, which is 17/12. But 17/12 is not the square root of 2. The issue, you might have figured this out, is right here. There's a bit of an overlap between these two slivers. So once I cut off the first sliver, I can't cut off the full second sliver. So what I end up with is not a perfect square, but I end up with this, 17/12, 17/12, and this little missing square is 1/12 by 1/12. Now this is going to lead to a process of estimating square roots. I'll teach you how this works. Over here, I have actually I'll do question number 2 since there's nothing written on there. This L-shaped thing has an area of 64 minus 1 equals 63. So just by looking at this, I can say the square root of 63 is approximately 8, which is true. But to get a better approximation, I'm going to do this equation where I cut a sliver off of here and off of here, and I want to find out what should the width of that sliver be so that it fills in half of this, each one fills in half of this missing square. So I say 8x is equal to 1/2 of 1 squared, or 8x equals a half, or x equals 1/16. So that means my new approximation is going to be square root of 63 is equal to approximately 8 minus 1/16. 8 minus 1/16 is a good approximation. Equals 127/16, which is very close to the actual answer. Let's move. This question over here says that this L-shaped thing is 12 squared minus 5 squared, which is 119. So the square root of 119 is somewhat less than 12, which is true. 12 times 12 is 144. So to get the better approximation, I draw in these two things and put an x here and here, and I say 12x, which is the area of this sliver here, should be half of 5 squared, because 5 squared is the area of this thing. So x equals 25/2 times 12. (25/24), which means that's how much is taken off. So the approximation is now going to be refined to 12 minus 25/24. 12 minus 25/24 is 263/24. I like to leave these as improper fractions. 263/24, just so you know, is about 10.958333, and when we square that, we do get 120.08, which is not the greatest approximation, but then again, this circle, this missing square is actually kind of large, so we'll learn how to fix that up in the next step. If you take this question from before, this one with the square root of 63 was 8 minus, you shave off these two little slivers, x, we say 8x has to fill up half this square, so 8x equals half of 1 squared, or x equals 1/16. So we subtract away 1/16. 8 times 16 is 128, so we get 127/16. Now that's our approximation, our better approximation. However, we can go even better by doing the process again. In other words, I filled in the sliver, and I have now this situation. Tiny little hole there. This is 127/16. This is 127/16. Remember that it was 1/16 was a little overlapping piece here. That actually ends up being the missing square here. 1/16, 1/16. So now I can do the process again. I can cut off two more slivers and say 127/16 times x should be half of 1/16 squared. This becomes x equals 1/2. I like to do this. I write 1/16 times 1/16, and I take the reciprocal, 16/127. Cancel out some of those 16s. Multiply the denominators together. 2 times 16 times 127 is 4064. So my even better approximation is 127/16 minus 1/4064. 4064 divided by 16 is 254. 127 times 254. I get 32258. 32258 minus 1 over 4064, which is 32257 over 4064. Now that divided by 4064 is 7.937, and when I square that, I get 63 with 1, 2, 3, 4, 5, 6, 7 with 8 zeros. So you see, you can do this process over and over again, and in doing so, I get this really nice approximation. And that's what the Indians did to get their approximations, and I have a sheet here with practice questions for you.